Our video today would like to look at data envelopment analysis, what we refer to as the DEA. I'm going to use the Tidyverse library and the RDEA libraries to be able to do that. And I would like to look at some Kenyan banks. And I have some data here that we're going to look at. And so let's view the data and see what the data has. So this is data for, we have 108 entries and there are 4 columns. So we have loans, interest income, interest expenses, and deposits. There are 9 banks for a period of 12 years. So it's 12 times 9, and that gives us 108. So the first one is the first bank. I'm not going to show the names of the banks, and we want to use that. So I'm going to select each column by itself, deposits on their own, loans, income, and expenses for each of the 4 columns that we have. So I pick each one of them. The banks are all there together. And then I'm going to create some empty matrices for each of the 4 columns: loans, income, expenses, deposits. So these are matrices. I'm creating empty matrices with 12 rows, and it will be with numbers between 1 to 108, and I will be using them. Then I also create a matrix for the pure technical efficiency, and also another matrix for the technical efficiencies that I'm going to estimate. So I'm going to use a simple loop to help me achieve that. For K from 1 to 9, I've said there are 9 banks, and then uh, the I from 1, 12 starting from I starting from 12. This is when K is 1, so this is 0. So I will start from 1, and then when K is 9, this will be 8. 8 times 12 is 96, so it is from 97. So what I'm doing is I'm trying to create a matrix that will, a loop that will help me feeding the data in the matrix that I have. So I'll do that iteration just to make my work easier. And I want to get the pure technical efficiency and the technical efficiency for each of the banks using, I have the loans, I have the income, and I have the deposit for each one of them. So let's find out what we'll get if we were to do this. So let me run these entries again, just to be sure everything is fine. I'm just doing Control Enter. And then at the end here, it helps me pick each one of them. So for example, let me view bank deposits. You see what it has done? I separated each of the bank. V1 is the first bank, V2 until the ninth bank for each of the 12 years. So that was the purpose of the loop. I decided to do a loop to help me separate them. You can do it manually or you can automate the process. So that's what I decided to do at this point, to automate the process so that I have value for each. Now, at this point, I want to get the PTE. So I get the bank deposits or the loans first column. So for example, if K is 1, I want to pick the first bank deposits and the first bank loans. And then I say X is equals to bank deposit for the first bank and bank loans. So here, basically what I'm doing is my model is looking at input as deposits and then output as loans. That's what I was doing at this point. And so I'm using an input model, and return to scale should be variable. And then from there, I get the data OPT for the model that I found here, and that gives me the score. So if I was to view, for example, if I was to view model underscore PTE efficiency, maybe all the rows first column, then it doesn't show me there because it's a more complex set of numbers. But if I view it on the screen, these are the 12 years for the first bank. These are the PTE scores. And I can also do the same for the TE scores for the first bank. So these are the technical efficiencies for the first bank for the 12 years. And then I can also check what are the technical efficiencies for the second bank individually. And then I'll be able to do so. If I wanted to get the SE, before I do get the scale efficiency, then I decided to save my work into my folder that shows me the scores all combined together. So if I say model TE efficiency, then it shows me all the banks, 9 of them, for the 12 years. And that's what I'm writing as a CSV file. I could as well decide to get the scale efficiency, which is a division of the TE and the PTE. So that's the simple process of going about doing a DEA. Now, maybe just to mention this, at this point, you are first of all saying X left should be your deposit, the bank deposit. So if it's the first column, you pick column for the deposits. And then for the second step is you have the Y left, which are your loans. So this is the input and these are the output. So you are calling it S left here, Y left here is the same X here and is the same Y there. And then your model can be an input or an output model. And then your return to scale, they differ. You can always check out on that. And then after that, you can get the model theta. If I was to come down here in the console and say model underscore TE, and then I put a dollar sign, I have the feasibility, I have the theta OPT, I have the lambda, and I have the lambda sum. I'm interested with the theta OPTE, and that is what gives me those. So if you are to pick different values, they apply differently, but you're interested, it says what is true and what is false. And if you are to pick something else, like go down here, you pick the lambda. It shows you the lambdas for the entries that you are doing, specifically that bank maybe you have picked. So these are the steps that you would take to be able to do data envelopment analysis using the data that you've been given. And I hope you've enjoyed the video. Thank you so much for watching.